Okay, so this today we talk about the chapter 9 polygon challenge problem. So the first one is we have a regular n-gon. We want to prove this is the trapezoid. So you know the regular n-gon can inscribed in a circle. Okay, so you can see if we have a center of O, and if we have n-gon, then we have each of them is an isosceles triangle. For example, this is A1 and A2. Okay, so we divide the arc into equal parts, right? This is the one parts. So this angle is equal to the arc is 2 pi over n. Okay, so each of this angle is the same. Now let's draw draw four sides. Okay, so A1, A2, A3, A4. Okay, so we have three sides here: A1, A2, A3, A4. Right? Then we want to prove this is the trapezoid. Okay, so for trapezoid, isosceles trapezoid, we already know the A1, A2 equals A3, A4, right? So we already know the two sides are equal. Now we want to prove it's a trapezoid, means they are parallel. So the goal is, if we can prove the A1, A4 is parallel to A2, A3, then we can A1, A4 is parallel to A2, A3, we are done, right? So now let's see how we can prove it. So in order to prove the two lines are parallel, okay, so normally we prove either the corresponding or the inner alternate angles are the same. So we want to prove the angles are the same, so we can tell them are the same, right? So now let's see. So we have this, and we are missing a cutting line, right? Let's do a cutting line here. Okay, so now let's see the angle. Let's compare this angle and this angle, right? So we know each arc, right? Each arc has the same angle. So this arc is the 2 pi over n. So this angle is 2 pi over n, right? And the inscribed angle here is half of the centric angle. So this is a pi over n. Okay, opposite to this arc, right? And also we can see this angle. This angle is opposite to this arc, right? This arc is also 2 pi over n. So the inscribed angle is pi over n. Okay, so these two angles are the same, right? So now you can see the A1, A4 is parallel to A2, A3. Based on these two, we know the A1, A2, A3, A4 is isosceles, is a trapezoid. Okay, then the second one is we want to prove that A2, A1, and A4 is 360 divided by n, right? So we know that this arc is 2 pi over n, right? That's 360 divided by n. And A3, A4, so you do A2, A3 plus A3, A4. 2 arc is plus 360 over n, so it's 2 times the 360 over n, right? So this is the centric angle, right? But the A2, A1, A4 is the inscribed angle. That's half of the centric angle, right? So it's 1/2 and 2 times 360 over n. So it's 360 over n. Okay, then next. So in our discussion of the regular n-gon polygon, we assume that every regular polygon has point of this. Prove that inside every. Okay, so let's see. For example, we have a regular n-gon, right? Let's using the two of the equal sides to let's drop the perpendicular bisector of the first one. Okay, so this is a1, a2, and a3, and let's drop the second perpendicular bisector of the second one. So this part is the 1, right? Okay, so based on the perpendicular bisector, we know the OA2 is equal to OA3, right here. And also we know the OA2 is equal to OA1. So now the OA1 equal to OA2 equals to OA3. Okay. Now since it's a regular gon, a regular n-gon, right? So this angle, this angle, this angle, they will also be equal, right? 360 over n. Okay, then we can have based on this, and we can prove the OA1A2 is congruent to triangle OA2A3. Then we find the centric point of the O. Okay, this is the A, and let's do the B. Let O be the center of the regular n-gon, and the A be one of the vertices. Prove that OA bisect an interior angle. Okay, let's see. Let's using this one. Okay, let's see. O is the center, and the OA2 is the OA2 is one of the connection from the vertices to the center, right? So let's prove this angle equals to this angle, right? Because we know A1, A2, A3 is one interior angle. We want to prove OA2 bisect A1, A2, A3, right? So we can see, we can using the, because we drop on the perpendicular bisector, right? So we have this side, this is the radius, the three sides are equal, and the angles also equal, right? So based on this, we can have the OA1, A2 congruent to the OA2, A3. Then we know the angle A1, A2O equals to angle the A3, A2O, right? So based on this, now we know the OA2 bisect the OA2 bisect this angle. Okay. So this one is the Pentagon. So we have a the right angle here, and it's a pentagon. So 5 sides, and we have the A, B, C, D, E. Then we have this one equal this one. Okay, so when we connect it, we know this is the isosceles right triangle, and these are all ones, right? And the BE is equals to 2, so we know this is the root 2, this is the root 2, so it's easy to calculate this. Okay, and we also, you have the BE parallel to CD. Now let's do a line. Let's see the CF is parallel to DE, so we know the CF parallel to DE. Now it's already know the BE parallel to CD. Now we can see the CDEF is a parallelogram. then we know this FE equals 1, right? And the BF equals 1. So, and this one also equals 1. So we have the BFC is equilateral triangle. So this is equilateral triangle, right? So we know this is the 60, and based on this, right? Based on this, we know the height. Okay, so the height is √3/2. Now we can calculate the area. So we can calculate the area of the ABE is half of the √2 times √2 is 1, and we can have the trapezoid. At such the trapezoid is BCDE is equal to half of the 1 plus 2 times the √3/2. Then we have the 4, 3, √3. So we add this together. It's the area. Next. So the total number of the degree of the sum of interior angle of two regular n-gons. So let's see, we have a n-gon, regular n-gon, and the regular m-gon. Okay, that's we have two regular gons, and the total number of the degrees of the interior angle is n minus 2 times 180, right, plus the m minus 2 times 180 is equal to the 1980. This is the first one, and the sum of the number of diagonals. So we know the diagonal is n minus 3 and times n over 2 plus m minus 3 times m over 2 is equal to 34. Okay, so now let's do the equation 1 and equation 2. Let's simplify these two equations a little bit. Then we have the m plus n is equal to the divided by 180, then it's 1, and the 180 is 180. 11 plus 4 is 15. And the second one, what we have is the n square plus the m square minus 3, then m plus n is equal to 68. Since m plus n is 15, so we know the m square plus n square is equal to the 68 plus the 45 is 113. So this is the 3 and this is the 4. Okay, so the question is ask us what's the positive difference between the number of the sides, right? The positive difference means m minus n take absolute value. So to calculate this, we need m minus n square is equal to the m square plus n square minus 2mn. Okay, so how we can using this two to solve the 2mn is the key, right? That's very simple. We know this part is 113. Now let's solve it. So the m plus n the square minus the m square plus n square is 2mn is equal to the 15 square minus 113, right? So this one tells us the 2mn is 112. Okay, if we know the 2mn is 112, so it's 1. Okay, so this is the 7 point of the star. Okay, so we want to ask you what is the angle A plus angle B plus angle C plus angle D plus angle E plus angle F and plus angle G. Okay, So the 7 star the vertex angle, right? So let's solve it by the very similar to the 5-point star. Okay, so let's draw a big picture here. Okay, so we draw this one. So what we can connect it is the we connect this and we connect this two. Okay, so we know this is the should be exterior angle of two angles, right? So now let's see which triangle it is. So we can construct some triangles to. Okay, so let's construct a triangle of this. And let's construct another triangle like this. Okay, so let me highlight one triangle. So this one is the exterior angle of this triangle. Okay, let me mark all this angle 1, 2, 3, 4, 5, 6, and 7, 8. Okay, so this angle is equal to the angle of the 1 plus 6. Okay, and this angle is equal to the let me have another color. Okay, so this angle is the exterior angle of this triangle. Okay, so this angle is equal to the 4 plus 7. Okay, now let's keep working on this. So now we have this angle, no problem, right? And 1, 2, okay. Okay, so now we have the angle A, right, plus the angle 4 and 7, and the angle 1 and 6 is equal to 180. This is the first equation. The second one, let's see if we have the angle E, right? Yeah, we have the angle E. We have the angle E plus the angle 5 plus the angle 2 is 180. Okay, now the third one is we have the angle D. Okay, angle D. So this is the triangle EGC, and we have another triangle DFB. Okay, DFB. So we have the angle D plus the angle 3 plus the angle 8 is 180. Okay, so now we can see if we add them up, right? We have the angle A, angle E, and angle D. Then we have the 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. That's the rest of the angle B, angle C, angle D, and angle, angle B, C, F, G. Right? So then we means we add all of them up is equal to 540. Okay, next. So we have a regular hexagon. and the equilateral triangle have the same perimeter. So let's draw a regular hexagon. Let's see its perimeter equals 6a. So we know this one is a. Now we know the equilateral triangle is 2a. So what is the ratio of the area? Okay, so the ratio of the equilateral triangle is √3/4 times the square of the sides. The regular of the hexagon is cut into 6 equal pieces of the equilateral triangles. So it's √3 times a squared. That's 1 piece times 6. Okay. So now we can calculate the area. Okay. So that's the area of the hexagon and the area of the triangle, right? So the hexagon over the triangle is equal to √3 is √3/4 is common, is gone. So it's the 6a squared over 2a squared. So it's 6/4 is 3/2. Okay, so this one, so we have a patio. A pattern is determined by a regular hexagon tile. We have a hexagon tile. We have the equilateral, and we have the square. Okay, so then it asks us the area of the hexagon tile is 96 inches square. And what is the number of the square inches? Okay, so you can see if we draw a little bit bigger, then it means this one is 96, right? It asks you what is the area of the square. So it's important to calculate the a, right? So we know the area of the is a square, right? And we also know 96 is √3/4 times a square, then is also times 6. Now we can see the a square is equal to the 16 is 64/√3. So now we have the 364/3, right? 64/3 divided by 3. So this is the area of the square. Now, what is the area of the whole tile, right? So you know this is we know the s square, right? And we can also calculating. We can also see the equilateral triangles. How many? 1, 2, 3, 4, 5, 6. 6 equilateral triangles. The 6 equilateral triangle can make another hexagon, right? Here is the 6. So now we know the equilateral triangle is 96 plus the middle of the hexagon is 96 plus then we have 6 sides and the 6 of the square. Then it's 6 times the 364/3. Then it is the 192. Then plus the 2 is 128/3. Next one is given that it's a regular hexagon. Okay, so we have a regular hexagon of the ABCDE EF. Then we want to have the side length of 12. We want to find the area of the ACE. So ACE. Okay, so let's find this is the center of the regular hexagon. Okay, let's see, this is the O, and let me draw some auxiliary lines. Okay, now we can see by it's a regular hexagon, so by symmetry we can see we have a rhombus here. Okay, we have rhombus here. Okay, now we have the area of the 1 and the 1, right? Then we have this area is also 1 and 1 and the 1 and the 1, right? So now you know the area of the ACE is 3 ones, right? And the rest of them are all the 3 ones, right? So now you know the area of the ACE is half of the area of the hexagon, right? So now we know half of the hexagon is 6 and the root 3 over 4 times the 12 square. So after calculation, it is 108 root 3. Next. So the interior angle of a convex polygon form a arithmetic progression with a common difference of 4 degrees, and the number of sides of the polygon if the largest. Okay, so we want to know what is the largest size. Let's see it's an n-gon. Okay, and we know the largest angle is 172. Right, this is the largest. This is for example, this is the nth angle, right? So we want to see what is the first angle. So the first angle will be the 172 minus the n minus 1 times 4. Okay, so now we have all the n angles, right? Now we know that all the n angles together is 1 minus 2 times 180 is equal to, we have how many 172? We have n times 172, right? And the rest of them we need to take out 1 plus 2 up to the n minus 1 is we need to take out. Then we have the n times 180, right? So we have the 8n minus 360 is equal to the negative 4 times the half of the n and n minus 1. Then we can keep solving this. We have this one is 2. Then we have the 2n square, right? And plus 2n, then plus 6n minus 360 is equal to 0. Then we can further factorize as n plus 15 and n minus 12 is 0. So n is equal to 12. The next, so we have opposite sides of the hexagon are parallel. So we know, okay, we know here is a rectangle, and we know this. Okay, so we have this one and this one. The opposite sides are parallel. So this one parallel to this one parallel to this, right? And also this one parallel to this. And we know the silence is 12 and 9 and 12 and 9. So 9 is 3 times 3. This is 3 times 4. This is 3, 4, 5, right? So this is 3 times 5. This is 3 times 5. So this is the 20. This is the 20. So now you can see it's easy to see all this, right? So because they are AD, given AD is 25, it's 15, This one is 25, right? So based on the 25, let's see, is 5 times 5, right? So we know it's 3 times 5. This is 4 times 5. So it's 3, 4, 5. So that's why this is 90 degrees, right? And they are parallel. And then we know this is the rectangle. Okay, so once we know this is the rectangle, then everything else is simple, right? So we can basically, these two triangles, 1 and 2, can make a rectangle, right? So this 1 and 2 make a rectangle is 12 times 9, then plus the 20 times the 15. This is the total area. 108 plus 300 is equal to the 48. So we want to determine the determine with the proof the number of positive integer n such that a convex, okay, the first is a convex. The convex means all the interior angle, okay, alpha int interior angle should be less than 180 degrees, okay, with n size has interior angle whose measure in degree are integers. So you know, I mean, we have the sum of the all the angles are integers, right? Are regular, okay. So all the angles, so n minus 2 times times 180 is equal to n times the alpha, right? We need this one to be integer, right? So you can think, if I have an n-gon, right? This is the alpha, right? And the exterior angle is the 180 minus alpha, right? If this one is the integer, then this one is also integer. Okay, then it's easy to know the sum of all the exterior angle, right? The sum of all the exterior angle is sum of the n times 180 minus alpha. This is the integer, right, is equal to 360, right? So that means the 180 minus alpha, this is the integer, is equal to 360 over n. So now we know we want to find the n to make 360 over n is the integer, okay? So 360 over n is integer, means we need to find the n is a factor of 360, okay, but also n need to be greater or equal than 3, because 2 there's no 2 gons, right? Then we need to prime factorization of the 360 is 6 squared times 10, then it's the 2 to the cube times the 3 squared times 5, okay. So we can calculate the total number of factors. The number of factors here are the 3 plus 1 and the 2 plus 1 and the 1 plus 1, okay. So it is 4 times 3 times 2. It is the 24, right? But we also need the n greater or equal than 3, right? Let's check. N equal 1 is a factor of this 360. N equal 2 is also a factor of 360, right? So we need to take out this 2. So 24 minus 2 is 22 is the answer. Next. So what is the largest possible of the interior angle of a convex pentagon? Okay, that can have a measure of 90. So let's do it. So a pentagon have a total sum of the interior angle is this, right? So let's assume the maximum we can have is x, right? So let's assume we have x of 90. So x times 90, right? And then the rest of them, we have 5 minus x left, right, of the angles. And if every angle become 180, right, but we cannot achieve 180. So if we get every angle of the rest is 180, this angle should be greater than this on the sum of the interior. Okay, so by solving this, we can see we have 5 times 180. 5 times 180 is here. Okay. Then we have the x times negative x, so we have the x minus 2 times 180 is less than x times 90. So we have the 2x minus 2 is less than x. Okay. So now we have the x should be less than 4. So the maximum of x is 3. Right? Then let me skip the B. Let me see the C. Okay, if we expand into the n-gon, right? So we have n minus 2 times 180 is less than, we see the maximum have x size can be 90, and plus the n minus 2 times 180, n minus x times 180, right? The same reason we think the rest of them are 180, right? Then we can see we have n80, n times 180. Then we have the x minus 2 times 180 is less than x times 90. It's exactly as the same inequalities, right? So x max is equal to 3. So no matter how many gons here, if it is convex n-gon, so the number of the maximum angles, interior angles that can be 90 degrees is 3. So this is the constructions let you to find. Okay, so we want to find how many polygons are possible. Okay, regular polygons are possible. So that means we can build. Okay, we can build. We can build for each vertices, right? There are 3 n-gons. Okay, for example, I have a regular n-gon like this. I have another regular n-gon like this, and another one like this. So for every point, you can see we have 3 of them connected each other. So that's why it led you to calculating what are all the combinations. Okay, so based on this, the only thing we need to know is this one constructed, the 3 interior angle constructed 360 degrees, right? So let's do let's assume this is a so let's assume this is the 3 polygons. Okay, now let's assume we have a M polygon first. And the second one, let's assume this one is from M, this one is a n-gon, this is the m-gon, and this one is a p-gon. Okay, now we know this angle regular n-gon is the n minus 2 divided by n times 180, right? This is the m minus 2 over n over m times 180, right? So this is the p-gon. So this is p minus 2 divided by p times 180. So we only know these 3 add together. So we have the 1 minus 2 over n times 180 plus the 102 over m times 180 plus the 1 minus 2 over p times 180. It's altogether is the 360 degrees. Now we can take out all this, the common things, right? So it's 2. Then we know the 1 equals the 2 over n plus the 2 over n plus the 2 over p. Then we can do that it's half equals to the 1 over n plus 1 over n plus 1 over p. Okay, so no matter how many guns, you need to be satisfied this equation to be able to satisfy to find all the possibilities to make this n gun, p gun, m gun together, right? So now let's solve it. So without loss of the generality, right? Let's make an order so we can see it's m less than n equal or n less than p. So now we can see is the 1/2, right? If we use the smallest of the denominator, then this number will be bigger, right? So we have 3 over n. Now this one, if we all replace with the biggest denominator, right? So this over p. So now we know the m should be less or equal than 6 and p should be greater or equal than 6. So if m is less than equal than 6, then we have the choice, right? We can have m equals 3, m equals 4, m equals 5, and m equals 6. Okay, so if m equals 3, right? This one means the 1 over n plus 1 over p is equal to, m equal to 3 is 1 over 6. Okay, so this is the equivalently to see the to give us the let me times the np. Okay, so give us the np minus 6 and minus 6p is equal to 0. Okay, if you further do this, we have a this is a pretty regular trick to deal with this is to factorize it. So n minus 6 and p minus 6 equals 36. Okay, now let's deal with the n equals 4. Then we have the 1 over m equals 4, 1 over n, and 1 over p is equal to the 1/4. So now we have the np minus the 4n minus the 4p is equal to 0. Then we have n minus 4 and p minus 4 is equal to 16. Now next one is 5, right? So this one is a little bit special. So 1 over p 1 over n plus p over n, 1 over p is equal to half minus 1/5. Okay, so we get is 10 over the 3. Then we have the 3np minus 10 and minus 10p equals 0. Okay, to deal with this, so we normally times the 3 on both sides. Okay, because we want some symmetry. 9 minus 30n minus 30p is equal to 0. Then we can further factorize 3n minus 10 times 3p minus 10, right, equals 100. Okay, the final one is the 6, right? It's 1 over n plus 1 over p is equal to the 1 over 3. Now we can further factorize it is the np minus 3n minus 3p is equal to 0. Then we have the n minus 3, then p minus 3 is equal to 9. Okay, so we have 1, 2, 3, and 4. Okay, now we need to find the integer solutions to all these 4 equations. Okay, now let's do them one by one. So m equals 3. Okay, m equals 3. Let's build a table. Then we can factorize the n minus 6, p minus 6, because p is bigger, right? So this is bigger, this is small, right? So we can solve the n and p. So we can starting with n is 1 and p is 36. Then n is 2 is 18. Then 3 is 12. Then 4 is 9. Then 6 is 6. Let's solve the n and p. Okay, so this is 7. This is the 42. This is 8, 9, 10, 12. So this one will be 24, 18, and 15, and 12. Okay, so all the n and p should be greater or equal than m. Okay, so no problem. So these are all the valid solutions. Now m equals 4. Okay, same thing. We need to build a table. Then it's n minus 4, n minus 4, and p minus 4, and then the n and p. Okay, now we can do, this one is the 16, right? So we can factorize it. So it's 116 and 2 8 and 4 4. Okay, then it's, this one is 5 and 20. This one is 6 and 12. This one is 8 and 8. All of them should be greater or equal than 4. Yes, all valid, right? Next is m equals 5. Okay, so m equals 5. We have the 3n minus 10 and 3p minus 10 equal 100. Okay, so the 3n minus 10 and 3p minus 10 equals 100, right? So it's n and p. Okay, so can we factorize as 100? Of course not, right? It's not integer. Then how about 2 and 50? Yes. Now next is 5 and 20. Yes. Next is oh, I'm sorry, I'm missing the 4 and 25. This one doesn't work, right? Okay, not work. 5, 6, 7, 8. 8 doesn't work. 9, 10, 10 and 10 doesn't work. So this one is n is 4 and p is the 60 is 20. Okay, but we need the n and greater equal than 5, right? So this one doesn't work. And this one is the 15 is 5. Yes, it works. Then this one is 30 divided by 3 is 10. So this is a valid answer. Now the final case is m equals 6. If m equals 6, we have n minus 3, p minus 3 equal 9. We have the n minus 3, p minus 3. Then we solve the n, and we want to solve the p, right? So it's 9, so we can have the 1 and 9. Then 3 and 3. So now we have the one is 4, and the other one is 12. And the one is the 6 and 6. So this n is less than that. So is this one not work? So that's all the solutions. Okay. So we have the 6, 6, 6. From here we have the 5, 5, 10. This one we have 3 is 4, 5, 20, 4, 6, 12, 4, 8, 8. This one we have the 3, 7, 42, 3, 8, 24, 3, 9, 18, and 3, 10, 15, and 3, 12, and 12. These are all the answers. Okay. So this one is we have ACB is 90 degrees. ACB. Then P, PC are regular pentagons. So we get the regular pentagon on all the sides. Okay. So this one, if you draw everything, it's kind of very messy, right? In this case, normally we only draw one pentagon. Okay. We try to find some the parameterize by only drawing one pentagon and to see it. Okay, let's draw one pentagon of this, call it PC. Okay, let's see what's going on here. So the regular pentagon, we have the center, right? Because they are inscribed in a circle. Right. So you can see the radius of each circle, okay, it should be decided by the side length, right? Because this angle is 180 divided by 5. Okay. So you can see if this is the C, right? So its radius is proportional to the C, right? So also its height is proportional to the C, right? So let's say it's C times T is the ratio, okay? So this ratio is a constant, T0, okay? Let's use the T0, means it's a constant. So that means the PC is equal to the half times the C times T0 is the height. Is then times we have 5 of them, so 5 over 2 times T0 is a constant times the C square. That's PC, right? So similarly, you can see the P from the A, right? This is the A, this is C, this is the B. So we have the PA is 5 over 2 times T0, then times the A square. Then PB is equal to 5 over 2T0, right? Times the B square. Okay. Now we can see, now let's see whether we want to prove the PA plus the PB equals PC, whether it's true or not, right? So PA plus PB is equal to 5 over 2T0. Then we have the A square plus B square, right? And PC is 5 over 2T0. We have the C square, right? For Pythagorean theorem, you know this one, right? So the answer you done, right? So this one final one is we need to draw, still need to draw a circle, okay? Because the let me draw this. Let's use this to have a nice picture. Okay. So let's also draw a square. Okay, now let's draw another one. Is okay. Okay, the other way I need to hand drawing. Okay, so you can see there the center is the same, right? They concentric. Okay, so now we have this one is the B, A, then H, and G, and F, and E, and D, and C. Okay, so what you can observe is this. Okay, so this is the after rotating, right? After rotating this one, so this side gets rotating to this side, right? So this point gets rotating to this point. This point gets rotating to this point by a angle of the theta. So this is the theta, right? And this point gets rotating to this point. That's also theta, right? And this point gets rotating to this point. This to this, 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 and this to this. Okay. So you can kind of see the kind of the symmetry, right? So the triangle of the of this one, this to this, right? So that's why this triangle gets rotating to this triangle, and this triangle gets rotating to this triangle. So that means all these triangles are congruent. So that means if this is the x, this is the y, right? So all these the triangles are congruent. So this is the x, this will be the y, and this will be the y, this will be the x. Okay, they're all symmetry. Then we have the 43 over 99 is the AB, right? So we can see first the Pythagorean theorem tells us x squared plus y squared equals 33 over 99 square. Okay. And the next one you can see x plus y is equal to the 1 minus, because each side is 1, right? 43 over 99. So this one is 56 over 99. Okay, so the question is asking us what is the area of let me use another color. The question is asking us what is the area of this octagon, okay? The A sides. Okay, so you can see the A sides is the square. Take out this, take out this, take out this, and take out this. Since they are congruent, right? So now we can see each area is half of the x times y, right? So we need to take out the 2 times y, right? So the 4 of them is 1, 2, 1, 1, 1, 1. The 1 is equal to this, right? So 4 times the 1 is equal to the 2xy. So since once we solve the 2xy, we solve this problem, right? So this is the 1 and this is the 2. So we know the 2xy is equal to the x plus y square minus the x square plus the y square. So it's equal to the 56 over 99 square minus the 43 over 99 of the square is equal to the this is the difference of the square, right? It's 99 over 99 times the it's 13 over the 99, so it's 13 over 99, right? And then the regular octagon will be 1 minus the 13 over 99. That's the 8. That's the 6 and 86 over 99. Okay, so that's it for this the problem of this chapter. Thank you.